Alright folks, Mr. Fuzek here again. We're looking at video E3p3-9. This set of notes is section 3-2. Volcanoes form as molten rock erupts, and we're still looking at, or we're going to start looking at E3p3c as our learning target, which is describing the three major types of volcanoes: shield volcanoes, stratovolcanoes, which are also known as composite volcanoes, and cinder cones. And then with all that, their relationship to the Ring of Fire. So how are volcanoes related to the Ring of Fire? So our task, we're going to watch this video. I will take you through number 11 in this video, and then E3p3-10, the next video, will take you the rest of the way through number 20 in these notes. Alright, so this is the document we're looking at, and I'm going to go ahead and switch to PowerPoint. Alright, here we go. Volcanoes form as molten rock erupts. So first off, what's a volcano? It's simply defined as an opening in Earth's crust through which molten rock, rock fragments, and hot gases erupt. And a mountain builds up from erupted material. So not just magma's coming out of volcanoes. Lots of things are coming out. Lots of material. And again, please use the pause button if I'm going a little too fast for you. So volcanoes can erupt violently or gently, and based on this, it's going to depend on the type of volcano that we get. So if we have violent eruptions, it's throwing huge amounts of rock and ash high into the air and over a pretty wide range, because the higher it goes, the further out from that volcano it's going to move. If it's gentle, it's generally just pouring out rivers of molten rock, okay, and they can flow long distances. Great example of a gently erupting volcano would be the Hawaiian volcanoes. So the violence of the eruption, though, depends on the type of magma feeding the volcano. That dictates everything. So in magma, it's composed of two things mainly. Silica, it's a compound of silicon and oxygen. It makes fluids more viscous. Okay, viscous is thick. Okay, in parentheses here I have like molasses. Okay, think of cold syrup or cold molasses, or even the corn syrup that you see in my classroom with the pressure builds lab. So this is very thick. And also gases, right? Expands as magma rises. Number 5, it says magma that's high in silica. So if it has a lot of silica, remember silica is making this fluid thicker, it's not going to want to flow, it's going to be thick. And so expanding gases get trapped. If they get trapped, pressure builds until there's a violent explosion. If magma is low in silica, it's going to flow easily. It can throw lava high into the air, forming lava fountains. But visitors can usually watch safely nearby. I personally have never been to Hawaii, but I know that you can go and get, I guess, relatively close to be able to view these lava flows and things like that. I see my typo here. It should say throw, not through. Excuse me. So 7, magma to lava. So magma rises towards the surface as long as it's less dense than the actual rock around it. Once it stops, it collects in the magma chambers until it cools to form rock or erupts. One of two things are going to happen. When it erupts, it becomes lava. Magma and lava are the same material, except magma's underground. Lava is what it's called once it's reached Earth's surface. So magma's underground, lava's on the surface. Here is a picture of a volcano, and it's showing you in red here all of the magma and or lava out here on the surface. Here's the magma chamber. So as this magma is less dense than the surrounding rock and brown here, these different layers, it's going to continue to rise. It can collect here and then end up shooting here as it moves up and come out this secondary cone, or eventually it can make its way to the top and erupt. And you can see here how eruptions one after another over long periods of time, have built up this volcano. You can see all these different layers building up this volcano, and this is a great example of what actually a composite volcano would look like, sort of steep sides like this. So it says volcanoes erupt many types of materials. First off, we have rock fragments. Material erupted from volcanoes, they can form in three ways. One, escaping bubbles, gas bubbles pop, tearing magma apart. Larger pieces of lava can be thrown into the air, cooling and hardening during flight. Or rocks can rip loose from the inner walls of the volcano during the eruption. Again, be sure to be using that pause button if you need it. So now it says there's three categories of rock fragments. We have ash, cinders, blocks, tiny particles of dust. Okay, it says up to the size of rice grains. Either way, they're pretty small. Cinders are larger than ash. They contain holes and tunnels left by escaping gases. So if you can imagine a rock with all these little holes in it, because gases were escaping during flight while it was hardening. It's kind of what these would look like. 3. Blocks or bombs. Blocks erupt as solid pieces of rock. Bombs are molten when they erupt and often have streamlined shapes. Okay, blocks are big solid pieces of rock, and bombs have streamlined shapes. Kind of think of a javelin or a spear almost, as that lava is flying through the air. It's hardening as it's flying and becomes sort of a spear shape. You can also get volcanic gases and then pyroclastic flow. Volcanic gases are usually a mixture of water vapor and carbon dioxide. Remember, volcanoes are a huge producer of CO2, carbon dioxide, in the natural world. Pyroclastic flow, for the last one here for this video, it says a dense cloud of superhot gases and rock fragments that races downhill. It can be as hot as 1500 degrees Fahrenheit and travel as fast as 100 miles an hour. Pyroclastic flows are very, very dangerous during explosive volcanic eruptions from composite or stratovolcanoes. We'll learn more about this as we do a case study later this unit on the Mount St. Helens eruption many years ago here in the United States. It was still the most recent and most devastating volcanic eruption in the United States.